The previous video I made was about empirical formulas. Now this is the continuation of that, and we're going to talk about molecular formulas. So empirical formulas just tell us the whole number ratio of the elements that are present in the compound. It is not specific. It can apply to many different compounds because many different compounds can have the same empirical formula. Okay, but the molecular formula is the actual number of atoms in a compound that tells you the exact chemical formula of that compound. Okay. Another thing to know that is the molecular formula is actually a multiple of the empirical formula. So if you know the empirical formula, you should be able to multiply it by a whole number to get the molecular formula. So here's what I'm talking about. Let's say you have the empirical formula of CH3. The only information you can get from this is that this compound, whatever it is, has a ratio of one carbon atom to three hydrogen atoms. And that could apply to many compounds, okay? But if you take this and you multiply it by a whole number, let's say 3, you get the formula for C3H9, which is tricarbon monohydride, and that is the molecular formula of, or the chemical formula of this compound, okay? If you were to multiply this by 2, instead of 3, then you would end up with C2H6, which is also a different compound. So both C3H9 and C2H6 have the same empirical formula, but based on what you multiply the empirical formula by, you get two different molecular formulas. So molecular formulas are more exact, and empirical formulas can be general to multiple compounds. Okay, now we're going to do problems similar to the empirical formula problems. It's basically an extension of an empirical formula question. Okay, so how do you determine a molecular formula? The first thing you do is find the empirical formula, and if you need to figure out how to do that, watch the video on empirical formulas on Google Classroom. Empirical formula video is on Google Classroom, everybody. So, if you don't know how to do the first step, go watch that video on Google Classroom. Then, the next thing you do is you take the empirical formula that you found and then you take its molar mass. And how do you find the molar mass? You use your periodic table. You add up all the masses from the periodic table. Then you divide the molecular formula's molar mass by the empirical formula's molar mass to get a whole number, n. So the number that you multiply your empirical formula by, I'm just going back to show you, this number, that's n, okay? So in order to get n, you have to divide the molecular formula's molar mass by the empirical formula's molar mass, and that tells you what number to multiply the empirical formula by. So then you take your empirical formula and you multiply it by n, and that gives you the molecular formula. Okay, now it seems like a lot of instructions, and until you apply these instructions, you're going to be confused. Now, you might ask, wait, how do I know this? The molecular formula's molar mass? That one is always given. You always get it. I'll be like, okay, here's the molecular formula's molar mass, and then you can just plug that in on top of this. Okay, so let's look at this question. I copied the instructions so you can follow along right here. All right, so the empirical formula for ethylene is CH2. So you don't know what the molecular formula for ethylene is. We know, however, that ethylene has one carbon to two hydrogens. Find the molecular formula if the molecular molar mass is 28.10 grams per mole. So molecular molar mass has been given to you. That's the number that's always given. That's this right there, okay? The empirical formula you don't have to find for this question because the empirical formula has also been given to you. It's right there. It's CH2, okay? So we have it. Now find the empirical formula's molar mass. Super easy, right? Empirical formula is CH2. So let's find the molar mass. It has one carbon and two hydrogens. So carbon's molar mass is 12.01 grams per mole, and then hydrogen's molar mass is 1.01, but since you have two of them, you just have to multiply it by 2. So 1.01 grams per mole times 2 gives you 2.02 grams per mole. So the empirical formula's molar mass is 14.03 grams per mole. Oops, sorry. 14.03 grams per mole. This is the EF molar mass. EF mass, that's for CH2. Okay, now let's switch colors. Divide, so that's check. Divide the molecular molar mass by the empirical molar mass to get the whole number. N, you are multiplying the EF by, so we're looking for N. The molecular formula's molar mass is always given. It's right there. So I'm going to do this. I'm going to set this up right now. MF mass over EF mass is equal to N. So this is equal to MF mass is right here, 28.10 grams per mole. EF mass we just calculated, it's right there, 14.03 grams per mole, and that'll give me N. So this is going to be probably very close to 2, but I want to be specific. So 28.1 divided by 14.03 gives me exactly 2.002. So you can round that to 2 because you need a whole number. So 2.002 is equal to N. Okay, so now the EF must be multiplied by N to get the molecular formula. So that's this. Okay, so the empirical formula is CH2. So if I multiply that by 2, that means what you're really doing is, actually let me write it better. What you're doing is you are taking the empirical formula and you're multiplying everything inside by 2. So 2 is N, okay? So 2 times the carbon gives you C2. 2 times the hydrogen gives you H4. So that is your molecular formula now, okay? So the whole point of this was to find N. N was 2. You multiply the empirical formula by the whole number to get the molecular formula, and your molecular formula is C2H4. Okay, now let's do a second problem. So again, the empirical formula has been given to you. If it wasn't given, you have to actually find it. All right, I don't know what I just did, but there we go. All right, so the empirical formula is CH4N. All right, you have to find the molecular formula, and you'll see that the empirical formula's molar mass, the molecular formula's molar mass is always given. It's always given, okay? So you don't have to find the empirical formula here because they have given it to you right there. Now, second step, find the empirical formula's molar mass. So here's the empirical formula, CH4 M. That means it has 1 carbon, 4 hydrogens, and 1 nitrogen. Carbon's molar mass is 12.01 grams per mole. Hydrogen's molar mass is 1.01 grams per mole, and we need 4 of these. And nitrogen's molar mass is 4.01 grams per mole. So it's 12.01 plus 4.04 plus 14.01. So let me add that up. 12.01 plus 4.04 plus 4.01. That gives me a molar mass of 30.06 grams per mole. That is the EF mass. Okay, now divide the molecular molar mass that's been given to you, that's this one, 60.11, by the empirical molar mass. So MF mass divided by EF mass is equal to N. So that's equal to 60.11 grams per mole over 30.06 grams per mole. 30.06. Sorry, kids. I keep hitting the forward button. There we go. 30.06 grams per mole, and that is equal to 1.999, which can be rounded to 2. Okay, it's 1.996. So that's 2. That's the whole number that we have to multiply our empirical formula by. So that is my n. Okay, so empirical formula times n gives you molecular formula. So here is my empirical formula, CH4 n. I'm going to times that. So 2 times the carbon gives me 2 carbons. 2 times the 4 hydrogen gives me 8 hydrogens. 2 times the n gives me N2. C2H8N2 is what we are looking for this question. Okay, so again, remember, if you are not given the empirical formula, you have to find it. Okay, and the way to find it is described in the video titled Empirical Formulas. Once you have found the empirical formula, you can proceed to find the molecular formula, which is basically the empirical formula multiplied by some whole number. The whole point of this is to find what whole number. So that's the whole number that you multiply the empirical formula by. Okay, so that's it for molecular formulas.